So getting past those qualities of water, we next start to talk a little bit about acidic and basic and the pH scale. So living systems are pretty sensitive to acidic and basic conditions. Your body is very sensitive to acidic conditions. You have a pH of, I believe, about 7.3. Your blood is about 7.3. Your stomach, on the other hand, has a pH of about 3. And so any change in those things, and it would start to seriously mess with your health. What we have when we're talking about acids and bases is we're talking a little bit about whether we have this extra hydrogen ion. The H is a positive, the OH is a negative, so this would be called an ionized hydroxide molecule. This is non-iodized water. So notice that they are two very different things. Water is good for life. Hydroxide ions not so good for life, not in the wrong circumstances. So the pH scale is measured through the amount of H plus, hydrogen plus, or the hydrogen ions in a solution, and that is called the pH scale. We have acids, which have a much lower pH, and bases, which have a much higher pH. Some of the ones that we talk about, acids like lemon, like vinegar, and there's some really strong acids that can eat through your skin. We have bases like ammonia. Milk is a base. Your blood is a little bit basic. So up here on the pH scale, your acids are 0 through 7. They have the H plus ions in them, which means they are very reactive. They are very corrosive to metals. So if you've ever seen somebody that has lots of rust on their car, that can be from getting rained on with acid rain for many, many years. And acids break down your food in your digestive system. So your digestive system has a pH between 2 and 3. And then as we get up here towards 0, we get very strong acids like battery acid. Soda is a strong acid, so that's one of the reasons it's really bad for the enamel on your teeth. Beer is acidic, coffee, and then we get to water. Pure water right here in the middle is 7. It's not an acid, it's not a base, it's neutral. So this is a good representation up here in the corner. The H plus ions are going to go towards the acids, the water right here in the middle, and then the OH ions. These are going to have more OH ions. These are things such as blood. We've got our baking soda, antacids, like if you have a really upset stomach and your stomach is too acidic, you can take an antacid and that will counteract the effects. We've got ammonia, which is a cleaning supply. Bleach, even stronger, really good cleaning supply, something that's used to kill off the bacteria. They are caustic to your skin. So whereas these like battery acid might eat through your skin, this is caustic to your skin. Do you remember the movie Fight Club, where they put the lye on the back of his hand? That's basically what was happening here. So bases are found in a lot of household cleaners. They generally taste bitter in taste, and they're kind of soapy. So one of the interesting things to remember about the pH scale is that each number that it goes up or down is about 10,000 times more acidic or basic. As we get from 7 to 3, this is about 10,000 times more acidic than water with a pH of 7. And so I believe it's going by 100 times for each step that it goes. So the pH scale is something that's really important to life because life is strongly affected by acids and bases. So talking about acids, acids have this H plus ion in it. It is very reactive. They donate that H plus ion to other chemicals, and so that's why something like your stomach acid can break down your food so well because it can donate very easily to other chemicals. Bases, on the other hand, have low hydrogen ions, and very high hydroxide ions, OH minus ions. These would be things like antacids, your baking soda, seltzer, milk of magnesia, anything that cuts the acid in your system. So here talking about blood pH, blood can quickly absorb excess H plus ions to keep a solution from becoming too acidic, and it can quickly release H plus ions to counteract any increases in OH minus concentration. So if your blood becomes too acidic, then putting in one of these buffer chemicals are going to make it so that it returns to normal. When blood levels become too basic, other buffer chemicals are going to be released by your body in order to counteract those and return it to normal. If your body chemistry gets too far off in any direction, it can make you very sick, and you can definitely die from that.